In this video, we'll be talking about arc length. Now we know that the arc length of a circle, and by that I mean this length of just the arc, just this piece of the circle, S. That arc length is proportional to the circumference of the circle, which is the entire distance around the circle, in the same way as the measure of the central angle, which I've shown here as theta, is to 360 degrees, or if we're in radians, that would be 2 pi radians. So I can use my formula for circumference of a circle, and if we're dealing with degrees, we can get the formula S is to 2 pi r, as theta is to 360. Now if we're in radians, and that's what we're going to be dealing with this section, we would have S is to 2 pi r, as theta in radians is to 2 pi radians. Now notice that the 2 pi's cancel, and I get a formula for arc length. We can cross multiply. S times 1 is equal to r times theta. So this formula we can use for theta in radians. If our theta, our central angle, is in degrees, it's easy enough to change that to radians and then use this formula, or we can use the proportion. Let's do a problem. A circle has a radius of 25.60 centimeters. Find the length of the arc intercepted by a central angle measuring, first, let's do 7 pi over 8 radians. So since we're in radians, we can use this formula, and all we have to do is multiply the radius, which is 25.60, times the central angle, which is 7 pi over 8. So my arc length is approximately 70.37 centimeters. Now let's do one with degrees. Again, the radius is 25.60 centimeters, and we're wanting to find the length of the arc intercepted by a central angle measuring 54 degrees. So first, convert to radians. And we do that by multiplying our 54 degrees by pi radians over 180 degrees. This is basically unit multipliers. So that gives us 3 pi over 10 radians. Then, using our formula, we get the arc length is equal to the radius, which is 25.60, multiplied by the central angle, which is 3 pi over 10. And our arc length then is approximately 24.13 centimeters.